Hello everybody, make sure that you have these notes in front of you and you have filled out your names so that when you submit the notes, we know who you are. Today we're going to talk about percent error, and percent error just kind of tells us how badly we mess something up. So for example, we have some gumballs here, and Mary guessed the number of gumballs and she thought that there were 158, but the real number was 200. So what we really want to do is find out what the difference was between the accurate answer and her guess. So we subtract first. And then when we get that, it should be 42, I believe. We have to compare that. It's always a comparison to the real number, which is 200. Go ahead and divide with your calculators. Divide 42 divided by 200. You should get 0.21. That's not a percent, that's the decimal. To change it to a percent, you move the decimal over 2 places. It's 21%. So she was 21% off. That was her percent error. So the biggest issue that we're going to have through this activity is knowing what the vocabulary means. So make sure that you know we're always going to take the amount of the error and divide it by the actual value that it was, and that gives us the percent error. So, for example, accepted or theoretical value is the quantity used by the general agreement of the scientific community. Blah, blah, blah. That's the actual value. That's what we really need to know. Mrs. Pearson and I will always refer to it as the actual value or the real value. The observed or experimental value down here, it's the quantitative value measured during an experiment. This is the value you get when you're doing the measuring. So this is like the guess, or this is the measurement that we got. That's usually the one that's wrong. Okay, make sure you have all this. I'm going to pause and go on to the next page. Sometimes you're going to see the formula look a little bit more like this one up at the top. It means the same thing. It's basically the difference between the guess and the real value compared to the real value times 100 for the percent. So let's just try one. Nika the dog weighs exactly, this is her actual weight. Let's write that on here. Actual. She weighs exactly 36.5 pounds. But when she was weighed on a defective scale, he weighed 38 pounds. Sorry, Nika is a boy. He weighed exactly 38 pounds on the scale, but that's not the actual amount. This was the guess or the measurement. So let's find out what percent of error that scale had. By doing this, let's subtract the actual versus the guess. So it's 38 minus 36.5. We're going to compare that to the real number. The real number was 36.5. And then we're going to multiply all of that times 100 for our percent. Okay, make sure you have all this. Go ahead and subtract for me with your calculator. 38 minus 36.5. You should get 1.5, and it's still over 36.5 because we haven't divided yet, and that's the percent error. I'm abbreviating a little bit here. Okay, so 1.5 divided by 36.5 should give us this, 0.04109 ... It says please round that to the nearest tenth. But first we need to change it to a percent. So multiply that number by 100. And you should get 4.10. This is the tenth, so we're going to keep it as 4.1%. Make sure you have this. I'm going to pause and scroll down. What if Millie the cat weighed 14 pounds on that same defective scale? What's Millie's actual weight to the nearest tenth of a pound? Well, we know that the scale is 4.1% off. If we multiply that by 14, This is the actual amount. If we multiply those 4.1% times 14, you should get 0.574. And I believe, if we are correct, I think that the scale was off going up, I believe. So Millie the cat should weigh 14. Actually, the scale was lower. Minus 0.574. So if you go ahead and subtract those two things, 14 minus 0.574, we should get 13.4, because we're rounding to the 10th, pounds. That's how much she actually weighs. Okay, I'm going to pause this and scroll down, make sure you have it. All right, so on this one, it says the actual length of a field is 500 feet. That's the actual. A measuring instrument shows the length to be 508 feet. Find the percentage of error. Okay, so we know we find the difference between the actual and the guess. So it's 508 minus 500. We're going to compare that to what it was actually. Multiply this whole thing by 100, and that's the percent error. Go ahead and take your calculators. I'm hoping you could do 508 minus 500 in your heads. We'll get 8 divided by 500. Multiply that by 100. Go ahead, use your calculators for us. 8 divided by 500 is 0.016 times 100. All I'm really doing then is moving the decimal 2 places to the right. I get 1.6%. Pretty close. That's a pretty close amount. Make sure you have this. I'm going to scroll up. Sophie measured a piece of paper to be 21.7 centimeters by 28.5 centimeters. A piece of paper is actually 21.6 centimeters by 28.4 centimeters. Determine the number of square centimeters in the area of the piece of paper using Sophie's measurements. So it says determine the number of square centimeters. All right, so all we need to do is use Sophie's measurements. That is this part right here. So to find area, all we do is multiply the length times the width. In this case, it's 21.7 times, I'm going to use parentheses so you can see my decimals and not percent sign, or multiplication signs. Use your calculator. 21.7 times 28.5, and you get 618.45. Now, how do we label area? Think about it for a second. Think about it. Centimeters squared. Very good. Now we have to do the actual area. Okay. Same formula again. Area equals length times width. Area is 21.6 this times 28.4. These seem like pretty close measurements. Use your calculator. I get 613.44. And how do we label area? Centimeters squared. Make sure you write this down before I scroll down. Okay, we are almost done. Now it says determine the percent error. Percent error. We are going to compare the guess versus the actual. For the guess, I believe we had 618.45. We're going to subtract 613.44. And the actual amount was the 613.44, I believe. Unless I did that wrong. So go ahead and subtract those two with your calculators. 618.45. Don't wait for me, by the way. Do this on your own. You better be doing this. I got 5.01. Please check me because sometimes I do things wrong. And I know I have to multiply that by 100 when I get done to get my percent. Okay, this 5.01 divided by 613.44 gives me 0.0082, let's say. We're going to round that, times 100. Just means move the decimal over 2 places. So it looks like our percent error is 0.82%. Oh, it says round to the nearest tenth. I didn't read the directions. So it's 0.8% error. Excellent work. Now try your quiz.